You sleep 8 hours and wake up exhausted. You've tried the supplements, the diets, the doctor visits, and nothing works. Here's what most people don't realize. Your fatigue might be written into your DNA. There are 15 specific genes that, when they have certain variants, can drain your energy at the cellular level, no matter how healthy you try to be. And the most frustrating part? Most doctors never test for a single one of them. Today, I'm breaking all 15 down, what they do, how common these variants are, the symptoms they cause, and what you can actually do about them naturally. Chronic fatigue is one of the most dismissed conditions in medicine. You're told your labs are normal. You're told to exercise more, stress less, maybe try therapy. But here's the thing. If your cells literally cannot produce energy efficiently because of how your genes are built, no amount of positive thinking is going to fix that. We're talking about genes that control methylation, mitochondrial function, detox, and inflammation. When these pathways are compromised, your body is essentially running on a dead battery all the time. So let's get into the 15 biggest offenders. First up, and probably the most talked about, is mthfr, which stands for methylene tetrahydrofolate reductase. I know, it's a mouthful. Here's what it does. It converts folate from your food into the active form your body can actually use, called methylfolate. This drives a process called methylation, which is involved in energy production, neurotransmitter balance, detox, and DNA repair. Now, the two most common variants are C677T and A1298C. About 10 to 15% of people are homozygous for C677T, meaning they have two copies. And those individuals can have up to a 70% reduction in enzyme function. Another 40% carry at least one copy. Symptoms commonly experienced with MTHFR variants are chronic fatigue, brain fog, depression, anxiety, poor sleep, elevated homocysteine, and slow recovery from illness. Natural support options to consider if MTHFR variants are driving your fatigue would be active B vitamins, specifically methylfolate and methylcobalamin. Be sure to avoid folic acid in its synthetic form. Riboflavin, B2, is also essential for MTHFR function, and magnesium supports the whole methylation cycle downstream. Gene number 2 is COMT, catechol O-methyltransferase. This enzyme breaks down dopamine, adrenaline, and estrogen. A slow COMT variant, the Val158 MET mutation, is found in roughly 25% of the population, which allows these hormones linger longer in the system. When this happens, you can experience fatigue that worsens with stress, anxiety, sensitivity to pain, hormonal imbalances, difficulty unwinding at night. Natural support options to consider to support slow COMT function would be magnesium, folate, and B12, and reducing high catecholamine inputs like excess caffeine and chronic stress. SAMe can also be helpful, but use cautiously if you frequently experience any anxiety. Gene 3 is SOD2, specifically the ALA16 Val variant. And this gene codes for an antioxidant enzyme inside your mitochondria, the power plants of your cells. When SOD2 is impaired, oxidative stress builds up inside your mitochondria, damaging the very machinery that makes your energy. Variants affect roughly 30 to 40% of people. Symptoms of SOD deficiency commonly present as post-exertional fatigue, muscle weakness, slow recovery, and worsening fatigue with exercise, classic for chronic fatigue syndrome. Natural support to consider are SOD cofactors such as manganese, CoQ10, N-acetylcysteine, and alpha-lipoic acid. These help buffer the oxidative damage. You can also consider supplementing directly with SOD enzymes. Gene 4 is a family of immune genes called HLA-DR, human leukocyte antigen. These genes govern how your immune system identifies and responds to threats, including mold toxins, Lyme, and other biotoxins. Certain HLA-DR variants, found in approximately 24% of the population, mean the body cannot properly tag and clear certain toxins. They just recirculate. Symptoms of HLA-DR gene variants present as fatigue triggered or worsened by water-damaged buildings, sensitivity to chemicals, brain fog, and chronic inflammatory response syndrome. If you have HLA-DR gene issues, taking binders like cholestyramine or activated charcoal are helpful while addressing the environmental exposures. Gene 5 is your TNF-alpha and related inflammatory cytokine genes like IL-6 and IL-1 beta. These variants crank up baseline inflammation in the body, keeping your immune system in a low-grade alarm state constantly. About 15 to 20% of people carry high-expression TNF-alpha variants. Symptoms when these genes are impacted are fatigue, joint pain, slow healing, mood issues, gut inflammation, and an exaggerated response to infections. Support with things like omega-3 fatty acids, curcumin, and resveratrol. Following a low inflammatory diet is a must when these genes are driving inflammation. Also, optimizing gut health is foundational, since 70% of immune signaling originates there. Gene 6 is BDNF, brain-derived neurotrophic factor. Think of it as fertilizer for your brain. BDNF supports the growth, repair, and survival of neurons, and it's deeply tied to mental energy and motivation, not just physical stamina. The most studied variant is Val66Met, found in roughly 20 to 30% of the population. Symptoms commonly seen here are rental fatigue, low motivation, depression, difficulty concentrating, poor stress resilience, and cognitive fog that no amount of coffee can cut through. Exercise is the most powerful BDNF booster, even short bursts. Supplements to consider would be lion's mane mushroom, omega-3 DHA, and magnesium threonate. Research shows cold exposure helps support for BDNF expression. Sunlight and quality sleep are non-negotiables here too. Gene 7 is NRF2, encoded by the NFE2L2 gene. This is your master antioxidant and detox switch. NRF2 activates hundreds of protective genes, including glutathione production, detox enzymes, and anti-inflammatory pathways. Variants that reduce NRF2 function are found in an estimated 20 to 25% of people and leave cells far more vulnerable to oxidative damage. Symptoms commonly seen with reduced NRF2 function are chemical sensitivities, fatigue worsened by environmental exposures, poor recovery from illness, accelerated aging, and low glutathione levels. Supporting with sulforaphane from broccoli sprouts is the most potent natural NRF2 activator known. Also consider curcumin, resveratrol, NAC, and quercetin. Reducing toxic load by reducing exposure to cleaning products and personal care products, while improving your air quality, amplifies the effect. Gene 8 involves your HPA axis, specifically genes like CRHR1 and FKBP5 that regulate how your body responds to and recovers from stress. These variants affect cortisol sensitivity and stress hormone clearance. Certain FKBP5 variants are found in 15 to 20% of people and are strongly linked to stress-related fatigue and burnout. Symptoms someone will typically experience would be a wired but tired feeling, morning fatigue despite sleep, inability to relax, slow recovery from stress, adrenal exhaustion patterns, and anxiety fatigue cycles. Taking adaptogens are the front line here. Ashwagandha, rhodiola, and holy basil all support HPA axis regulation. Phosphatidylserine helps blunt excess cortisol. Prioritizing sleep and reducing blue light exposure at night is critical for resetting this axis. Gene 9 is SLC6A4, the serotonin transporter gene. It controls how efficiently serotonin is recycled in the brain. The well-known variant here is called the 5-HTT-LPR short allele, found in roughly 40% of people in at least one copy. This isn't just about mood. Serotonin also regulates sleep cycles, pain perception, and energy rhythm throughout the day. Symptoms here would include fatigue with a mood component, low energy tied to low motivation, poor sleep quality, heightened pain sensitivity, carbohydrate cravings as a self-medicating pattern, and seasonal energy dips. Supporting with 5-HTP, a direct serotonin precursor, tryptophan-rich foods, adequate sunlight for serotonin synthesis, and especially gut health support. Up to 90% of serotonin is made in the gut, so optimal gut function is vital. Magnesium and B6 are also essential cofactors for serotonin production to consider as well. Gene 10, one of the most underappreciated on this list, is PPARGC1A, which codes for PGC1 alpha, often called the master regulator of mitochondrial biogenesis. In plain English, this gene controls how many new mitochondria your body builds and how well they function. Variants, found in roughly 20 to 35% of people depending on ancestry, can significantly reduce mitochondrial output. Someone can experience exercise intolerance, slow metabolism, persistent physical fatigue, even with adequate sleep and nutrition, poor cold tolerance, and difficulty building or maintaining muscle when this gene is impacted. Regular aerobic exercise as well as cold exposure are the two most potent activators of PGC1 alpha. Supplements that support mitochondrial biogenesis include CoQ10, PQQ, resveratrol, and NAD+ precursors like NMN. This gene responds powerfully to lifestyle, which is genuinely good news. Now we're going deep into the mitochondria, and this is where things get really interesting. Gene 11 is NDUFS7, one of the core subunit genes for complex 1 of the mitochondrial electron transport chain. Complex 1 is the very first step in converting NADH, the energy molecule made from the food you eat, into usable ATP. It's essentially the entry gate for cellular energy production. Variants in NDUFS7 and related complex 1 genes like NDUFV1 and NDUFS1 impair how efficiently electrons flow through this chain. Reduced complex 1 activity is one of the most commonly reported findings in people with chronic fatigue and myalgic encephalomyelitis. Symptoms commonly experienced are profound fatigue that is completely disproportionate to activity, post-exertional malaise, muscle weakness and cramping, brain fog, lactic acid buildup, and intolerance to exercise that would seem mild to others. Consider supplementing with NADH, as this directly feeds complex 1. Also, consider CoQ10, as this is the electron carrier that complex 1 passes electrons to and is absolutely essential. Riboflavin, or vitamin B2, is a direct cofactor, while B3 as NMN or NR supports NAD+ pools upstream. Avoid taking statins and other mitochondrial stressors if this pathway is compromised. Gene 12 is POLG, the gene that encodes the enzyme responsible for copying and repairing mitochondrial DNA. Your mitochondria have their own separate DNA, completely distinct from your nuclear DNA. POLG is the only polymerase that maintains it. Variants in POLG, found in an estimated 1 to 2% of the population in pathogenic forms, but with milder functional variants much more common, which can lead to accumulated mitochondrial DNA damage over time. This is a gene where the effects compound with age and with environmental stressors like alcohol, certain medications, particularly some antivirals and antibiotics, and high oxidative load. Symptoms include progressive fatigue that worsens with age, muscle pain, exercise intolerance, neurological symptoms including tingling and cognitive decline, and difficulty recovering from infections. Mitochondrial antioxidants are the priority: CoQ10, alpha-lipoic acid, and vitamin E. Avoiding mitochondrial toxins such as alcohol, excessive acetaminophen, and certain antibiotics like fluoroquinolones is critical. PQQ supports mitochondrial DNA integrity. This gene responds well to intermittent fasting, which triggers mitochondrial autophagy and clearance of damaged mitochondria. Gene 13 is SDHB and SDHD, the succinate dehydrogenase genes, which code for complex 2 of the electron transport chain. Here's why this matters. Complex 2 sits at the intersection of the Krebs cycle and the electron transport chain. It takes succinate, a metabolite produced in the Krebs cycle, and converts it to fumarate, simultaneously feeding electrons into the chain to generate NADH and FADH2 for ATP production, which equals energy. When SDH function is reduced, this creates a bottleneck. Energy doesn't flow, and importantly, succinate builds up, which actually triggers inflammation as a danger signal in the body. Variants affecting SDH function are estimated in roughly 5 to 15% of the general population. Experiencing deep fatigue, shortness of breath with exertion, headaches, poor stamina, and in more significant variants, a connection to hypoxia-like symptoms even at rest, are common symptoms when SDH is impacted. Riboflavin is the direct FAD cofactor for complex 2. This is non-negotiable. Iron is required for the iron-sulfur clusters in SDH, and succinate itself can be supplemented to help push the reaction if needed. CoQ10 again supports electron flow downstream, and keeping the Krebs cycle well fueled with magnesium, B vitamins, and lipoic acid is essential. Gene 14 is TFAM, mitochondrial transcription factor A. If PGC1 alpha is the general contractor who decides to build more mitochondria, TFAM is the foreman actually directing the construction. TFAM activates transcription of mitochondrial DNA and is essential for packaging and protecting it. Without sufficient TFAM activity, mitochondrial gene expression drops, meaning even if you have enough mitochondria, they can't express their full energy-producing potential. Variants affecting TFAM expression are an emerging area of research, with functional polymorphisms identified in roughly 15 to 25% of studied populations. TFAM activity also declines naturally with age and with chronic inflammation. Symptoms commonly seen with TFAM are fatigue that worsens progressively, reduced aerobic capacity, mitochondrial aging patterns, poor recovery from illness or surgery, and metabolic slowdown. Natural support such as PQQ, pyrroloquinoline quinone, is one of the most direct stimulators of TFAM expression and mitochondrial biogenesis. NAD+ precursors activate SIRT1, which in turn activates PGC1 alpha and TFAM. Berberine, resveratrol, and regular aerobic exercise all amplify TFAM activity as well. And the final gene, and this one is rarely talked about outside of mitochondrial medicine, is SLC25A4, which encodes ANT1, the adenine nucleotide translocator. ANT1 is the protein that sits in the inner mitochondrial membrane and performs one critical job. It swaps ADP for ATP, shuttling fresh ATP out of the mitochondria to power your cells and bringing depleted ADP back in to be recharged. Without this transporter working properly, ATP literally gets trapped inside the mitochondria and can't reach the rest of your body. Variants in ANT1 are found in roughly 5 to 10% of people and are considered one of the underdiagnosed contributors to exercise intolerance and chronic fatigue-like presentations. Symptoms experienced are severe exercise intolerance, muscle weakness that's out of proportion to fitness level, fatigue that hits like a wall rather than building gradually, and notably, elevated resting lactate in some cases. Taking D-ribose is the most targeted support here. It directly replenishes the adenine nucleotide pool inside mitochondria. Magnesium is also essential, as ATP exists almost entirely as MgATP in the body. CoQ10 keeps the electron chain flowing so there's ATP to export in the first place, and reducing mitochondrial stressors, including heavy metals, oxidative load, and excessive training without recovery, is essential for protecting ANT1 function. Before we wrap things up, here are 3 things I really want you to lock in. First, these genes tell one coherent story. MTHFR and B vitamins feed NAD+ production. NAD+ fuels complex 1. Complex 1 drives the electron transport chain. TFAM and PGC1 alpha build the mitochondria that house all of it. And ANT1 is the door that lets the energy out. Every single gene on this list is a piece in the same energy production network. Second, variants don't mean destiny. Every one of these 15 genes responds to nutrition, lifestyle, and targeted supplementation. These are tendencies, not sentences. With the right support, you can work with your biology, not against it. And third, genetic testing is more accessible than ever. Tools like 23andMe and Ancestry, combined with interpretation platforms or direct functional genomics panels through a practitioner, can tell you exactly which of these 15 are relevant for you. So you're not guessing and not spending money on supplements you don't need. If this resonated with you, do 3 things right now. Like this video so more people can find it. Subscribe or follow if you want to go deeper into the root causes of fatigue, hormones, and metabolic health. I will continue to post content designed to help you understand your body at a level your doctor probably never explained. And if you're not sure where to start with genetic testing, go to our website, www.anhcg.com, for more information. Thanks for watching.